Sketch the logarithmic function, label 3 points that lie on the graph, and determine the domain and the equation of any vertical asymptotes. The equation that we want to graph is h of x equals log base 4 of x. This is a logarithmic function. And as I look at this logarithmic function, I don't see any transformations to it, so this is just one of the basic logarithmic functions. But I'd like to write this, instead of h of x equals log base 4 of x, I'm going to write it as y equals log base 4 of x. And the reason I'm doing that is because I'd like to write this in exponential form instead of logarithmic form. It's much easier for me to find ordered pairs in exponential form than in logarithmic form. So if I write this in exponential form, it would be a base of 4 to the power of y equals x. So now I'm going to find some ordered pairs. Notice it says to label 3 points. So we want to find at least 3 points, but I like to find 5 because I get a much better defined graph when I have 5 points. So usually when I'm making a chart like this of x's and y's, I would choose x's and find y's. But we only do that when our equation is written in y equals form. I've just rewritten the equation so that it's in x equals form. So this time I'm going to choose y values and find the x's. I'm going to choose just a standard set of y's, -2, -1, 0, 1, and 2. We'll substitute these in to the equation 4 to the y. I'm going to start down here where the values are a little bit easier to simplify. 4 to the first power will be 4. 4 to the second power will be 16. 4 to the 0 is 1. 4 to the -1 is 1/4. And the reason I get 1/4 is because I'll use that negative in the exponent to tell me to find the reciprocal of the base. And 4 to the -2 will be 1/4 squared, which is 1/16. This gives me a set of ordered pairs. 1/16 -2, 1/4 -1, 1 0, 4 1, 16 2. I'm going to plot these ordered pairs. 1/16 and -2 would be about here. 1/4 and -1 would be about here. 1 0 would be here. 4 1 and 16 2. So 12, 13, 14, 15, 16 is a little off my grid, but we can still see it about right here. These 5 points connect very smoothly, and you can see how the pattern would continue on the right and on the left. Our graph would go down to -infinity. This logarithmic function will have a vertical asymptote that sits right on top of the y-axis. The vertical asymptote being the vertical line x equals 0. And you'll also notice that the graph is only showing up to the right of that y-axis. Logarithmic functions can only accept positive values inside of the log. And so we have a domain of 0 to infinity for this logarithmic function. So we have a graph where we've labeled 3 points, we've determined the domain, and we've determined the vertical asymptote for this log function. Thank you for checking out my videos. Have a great day.